Welcome to one of our most special TGIFs in a while. It's the culmination of a lot of work, a lot of crazy nights and days, and it's just a checkpoint in what our vision of the future is, which is there has to be a counterweight to nihilism. You know, it's like they say the only way to train models is via hyperscalers. They say you need to buy Jensen's latest GB5000 and whatever. And we say no, we say fuck you. We are going to take whatever kind of GPUs you have over the internet and we're going to train models. They go, oh no, it's not possible. It's going to be too slow. We said, no, fuck you too. We are going to prove to the world that there is another way. So today we are launching Covenant72B. It's not just a testament to the power of Bittensor because, you know, a lot of people will ask me, like, why don't you go fork your own L1 and, you know, you make a lot more money and blah, blah, blah. But because they don't get Bittensor. What did Bittensor do? Bittensor allowed a single dev without any knowledge of ML scale from 1 billion to 72 billion parameter models in the space of 9 months. There is no ecosystem on earth capable of that. So when we talk about all our problems, it is by hope that Covenant shoots and all these tools of prophecy show you that, okay, there's a lot of pain in Bittensor, but let it also be known that there's a lot of joy. And like, you know, sometimes this shit works. And when it works, it's fucking crazy. So we have Const on stage now. We're just going to talk through the early days of Templar and significant findings on the paper. So we're going to go all the way back to October 2024 when Const was teaching me ML. Yeah.
So, I forgot that you don't know anything.
Yeah, I still don't know anything, but luckily I earn enough permissions to pay people that do. Cool. So, like, there's no secret that Const literally wrote V1 of Templar. That back then. So he wrote V1 of Templar, and stupidly we thought it was going to work. So he wrote it, and I thought he was going to run it with me. I was like, yeah, fuck off. Go build this shit. So then it started the first version of Templar, which was very much like ExoSparta, which Pluralis is using in their current thing. So we went through that. There's always been easier ways to do this because, you know, training is one of the most chaotic things you can ever do permissionlessly. But rather than, you know, throw the baby out of the water, from day one, Templar tried to be true to both Bittensor and even to the ethos of decentralized systems. So we went permissionlessly and, oh my God, let me see those miners. Do I have any miners here? They're all hiding. But they fucked with me. They hacked us nonstop. And I don't know, but for this, it's a technological marvel, but also a journey into self because everything was fucked up and Const used to tell me, oh, you're overwhelmed. Then one day, something very crazy. Yeah? He went into my channel and told them I needed help. And I was like, get the fuck out of here. Why are you making me look vulnerable? I was very pissed off. And he gave some miners like 100 tau to do something I could have vibe coded in 20 minutes. And I kept saying, Const, why the fuck are you doing this? But it was a very important lesson. And the lesson I tried to teach or the subnet owners is that, bro, don't fight your miners. If you keep fighting your miners, there's two things. One, you will either burn out, or two, you will throw the baby out of the bathwater and do things to neutralize them. So that single act of Const going, I'm sure if you search my channel, you can find it. That single act of vulnerability really literally changed the course for us. So yeah, cool. Enough soft stories. Let's talk about Covenant72B. Now, to our knowledge, this is the largest instantiation of decentralized compute for training ever. And it's been crazy. So we did this, and to get here, we had to conquer a lot of things. First off, in March 2024, we released Gauntlets. In Gauntlets, what did we address? We addressed the thing that was most important to us, which is permissionless nature of things. How do we get untrusted, self-serving miners How do we use incentives to force them to do what we wanted to do? So we had Gauntlets. This was interesting to us, but we weren't attacking the center of ML training. We were still doing how we want the system to run. Because for us, permissionless systems are very, very important. The problem we try to solve is subjectivity, the human in the loop. So unless we have permissionless systems, we can never give up control. And as long as we still have control, the system remains corruptible. So we solved that. And it was like, okay, wow, what's next? It's like, Jesus Christ, we need to go hire people that actually understand ML. So after that, we dealt with the next level of complexity. We realized that, okay, we used Gnosis demo and we had lessons to learn from it. So the next thing we had to do was, okay, now that we can get them to work permissionlessly, never been done before. Because it's different to have it permissionlessly, but having incentives in the system, having the system directed by incentives, introduces so many failure states. So we got that. They said, okay, this is pretty slow. How do we speed this up? Then the lovely research guys, I told them, fuck off, go work. And they went back and they came back with SparseLoCo. Now, to our knowledge, SparseLoCo is still state of the art for decentralized training. What problem are we solving now? Okay, we solved permissionlessly. How do we solve the communication complexity? Because not only do we need to train permissionlessly, we can't spend 5 years training. So that's what SparseLoCo gave us. And it's worked really, really well. We'll be dropping the model and the paper later today. But again, it's as good as GPT-3/LLaMA-2. Now, it's not frontier yet, but we like to look at it as a small step for decentralized training, but a massive leap for mankind. Because, if in the space of 9 months, this is possible, where will we be at the end of the year? I am unbelievably bullish on the team. Const, over to you.
Isn't that quote inverted? It's a small leap for mankind and like a massive leap for decentralized training.
I don't know. I'm not too. English isn't my first language. I'm Nigerian.
Well, because I think that, like training a LLaMA-70 in 2026 is it's not going to change a lot of people's lives. But in the field of decentralized training, a 70 billion parameter model trained over the internet with incentives is the first of its kind, the largest machine learning model to train at that size and with the best algorithm for doing it, is very significant. And I'd like to know, where is the next frontier for you guys? So hitting the 72 billion parameter model, that's going to go and it's going to be fine-tuned on gradients, and then RL fine-tuned on Grail, and then eventually put into Affine when it's performant, and hosted on chatbots. And we're going to take this, as far as we can go. But that's you're not setting your sights on that. So what is the next step for Templar?
So it's good to be honest, and we have SFT this model, but one thing we always have to contend with is the frontier keeps moving exponentially, so we need to move even quicker. Now, as great as it is, it's trained on 1.1 million tokens. Frontier today is trained on 20 billion. And there's also things we need to improve on our core algorithms. We need to be able to train a lot faster, because right now, using just SparseLoCo and the current state of things, the MFU, which is how well a model uses the hardware, is not great. So in order to be able to do 20 trillion tokens in a short amount of time, we are focusing on the crusade. So one thing the Crusaders did, that rather than a team working behind closed doors, can we expose our problems to the miners, and can they destroy it? And that's what's happening. So with Crusades, we'll be able to raise the MSU of our machines, of our training runs, which means that we exponentially increase how fast we train. That's step one. Now, step two is, everyone probably saw the article from Epoch AI. The decentralized trading is growing, but we're still 300 times lower than the frontier, which is true. So we also need to cover this compute gap. Now, I've spoken to my colleagues, other subnet owners, And there's a camp that thinks that we need to buy more B200, we need to buy more compute. That's fine, but it's not how I think Bittensor can ever address a problem, is by looking at the centralized party and trying to outcompete them by doing what they're doing. We will always lose. So this is what brings us to Bittensor. Through scarcity, we will always innovate. So the next frontier for us algorithmically is saying, okay, right now in Covenant-72B, we needed at least 20 B200s to train the model. What if we didn't care about the type of compute? What if we could have clusters of data center compute and clusters of a lot cheaper compute? Because the scaling laws are more of the hyperscaler revenue laws. We don't believe that, necessarily you always have to have the latest hardware to be able to compete at the frontier. So our work with Heteroloco is going to be combining data center compute with any type of compute we can have there.
You say
So
Heteroloco?
Yeah, well, no, Bell refused to call it Heteroloco. He insists on calling it Heterogeneous SparseLoCo.
Short form is Heteroloco.
Okay, which you say that to him like
I love it. So SparseLoCo, the original version of this algorithm, requires that people all have B200s, basically.
Yes.
And Heteroloco removes that limitation. Like, how does it remove that limitation? Are you guys doing pipeline parallel where like the miners can take on just sections of the model?
Exactly.
Okay.
So shout out to Riley's, because they were the first people to make pipeline parallel practical within the setting or within the decentralized training setting. But what their current algorithm restricts them just to pipeline parallel. But for us, we're saying, okay, can we have DDP, which is data parallel between islands of compute? So we've reasoned about things as islands of compute. So we have some data parallel clusters, then we have clusters that just do pipeline parallel, then communicate outwards via data parallel. So this is what we've been working on. This is the next iteration of Templar. And we hope to be able to scale nodes, because again, there's a couple of things that's happening now. There's even the normal B200s, they're scarce now. So what we're saying is, you know what, fuck your scarcity, give me whatever compute you have. We will tie this up into a mighty cluster that will deliver as many or even more flops than the current computers do. So it's a massive undertaking, but via this, hopefully by the end of the year, Templar is training trillion parameter models.
One of the original critiques with SparseLoCo was that you can't scale the number of nodes that broadly. So in your guys' training run, like the number of peers for a single roll up of a gradient was about 20, 28, correct? And each one of those was a B200, 8x. But to get to, frontier model size, you would need to have a lot more nodes, and SparseLoCo potentially can't scale in that direction in the number of nodes. Is this one of the things that's being approached with Heteroloco?
So we could do a lot more nodes with SparseLoCo. I think we could do like 50 to 70, but we had to stop because of the price. That was what was stopping us from adding more nodes to Heteroloco. It was the price. So by having clusters that can be cheaper, the unit cost can be cheaper and can also be more volunteer as opposed to competitive, we can break this price thing. Because the algorithm is good, it works, but we limited it to 20 because at that price, we could only guarantee 20 nodes.
Right. Okay. So that limitation was spurious. It didn't exist. You could go very broadly and 70 nodes, still maybe not enough. Like, how do we go to 10,000 nodes?
So it depends. I need to get the exact number of how we scale that, but that is not even for us. That is not the biggest problem because I believe the research guys know how to do that. It's how many clusters can we physically get? That's what interested to us now. I mean, if we were scaling on just the pipeline parallel side, then that's more important. But for us, we're scaling along a data parallel axis. So we're saying, let's build these massive clusters, but some clusters can be made of far weaker computers. Some cluster can be a B200. Another cluster could be 50 RTX 900s. So we will keep scaling. I think that's how we want to scale, because it gives us a lot of efficiency over just pure pipeline parallel.
Yeah, makes sense. What is the aspect of Heteroloco that allows it to work with heterogeneous nodes? Like, tell us more about that.
So Heterogeneous Loco introduces pipeline compression within its own boundaries. So it's like, imagine the current state. We have 20 SparseLoCo nodes. Yeah, we have 20 B200s. Heterogeneous Loco would say, okay, instead of 20 B200s, can we have 15 B200 clusters with 5 random clusters? And all we care about is being able to absorb the model. So each model, each cluster still needs to DDP, still needs to data parallel the model to itself. But within that cluster, they will communicate via pipeline parallelism. And why is this possible? Because of, in addition, the local does very long local steps. So within that time, we can do the gradient accumulation, the forward, backwards via pipeline within that cluster and send the gradients out.
Does this allow you to have nodes in the network that just run a couple layers?
Yes, definitely. So because for us, we still want to be able to leverage, again, you need to be practical. Like, having every single thing running different layers, for us, it's not as practical because, again, our aim is to be the most performant decentralized training network in the world. And how do we do that? It's by some pipeline, but still data parallel. So from the outside, we're irrespective to compute, but the actual network topology is to assemble that compute where it fits. So if you're at B200, you go there. You're at A100, you go there. And like Lego pieces, we assemble all these islands of compute.
So like when combining this with, the issue of cost, the benefit here is that 3090s and 4090s are relatively cheap. So if you can split horizontally and train over many more clusters, hypothetically you can pull in a whole bunch of cheap machines to do this. Like, is that possible at this point with Heteroloco in a way that it wasn't possible with SparseLoCo?
100%. We're not going to go to the Mac Minis just yet. We're probably going to start with like A100s, then AMDs. But again, it's to be indifferent to compute. So the compute scarcity is data center compute. The compute scarcity is well-connected NVLink compute. But if we can train over the internet and we don't care where that unit of compute comes from, and we can make it efficient, then sky's the limit. I honestly believe this is how decentralized training catches those mega models. Because honestly, even if we use the whole of Bittensor's emissions to buy GPUs, we still can't scale like that. You understand?
If we're paying top prices for NV-linked B200s. But what you're saying here is that you're basically shorting bandwidth and longing latent compute and saying, hey, the biggest issue for training is this interconnect and the requirement for combining model updates. We sever that with the algorithm, and it allows us to pick up all of this relatively free compute. I mean, for instance, H100s that have become obsoleted for big labs, and 4090s and 3090s, et cetera, which people are just giving away at this point. You can soak all of that up into a single training run. How is, like, let's say that I had access to a 3090 on my desktop. Like, that's not enough to own a UID in the network. Are you guys thinking about ways in which you can scale beyond like the standard UMA consensus, the 256 limit, to allow for somebody that's just running, like, say, OpenClaw here, just like run OpenClaw, here's this thing, and you can mine in the network?
Yeah, so we would have to convert some of the UIDs into rigs. So take, for example, it could be B200, then we reserve some UIDs where we plug in like mining rigs. So we start to visualize training like mining, and okay, you only have one B200. We would pair you up with enough compute and pay you fractionally what you'd have earned. Does that make sense?
Mm-hmm.
It's the same
basically building minor pools on the UIDs.
Yes.
That's super cool.
So the next stage is, and so everything is starting to come together. Like, again, each of our subnets has a purpose. So anyone that's done training understands that it is a crazy, chaotic thing. The stages keep extending. When we started Templar because the very thesis of decentralized training is that the compute budget required to train these models is very, very large. And that's just pre-training. When Grok 2 dropped, it was the first time a lab had said, okay, push training is also 50%. So the good news is we can already train massive models on Grail. But we're not going to put Templar through it now because we just need a lot more tokens in the next run. So what does the future look like? It is more efficiency. There's going to be a smaller run to test the efficiency, then a bigger run where we put all we have again into Templar, put it through Grail, and hopefully serve it on Basilica. And that completes the Holy Trinity. Well, we will be dropping the model at around 5 p.m. EST, and the main reports on Monday. Thank you all very much for your support so far. I know it's been crazy, but thank you guys all for the support. And, we will continue to try to manifest the prophecy that is Bittensor. Thank you very much, guys. Bye.
Amen.